I push on a 50 kilogram block initially at rest with a force of 50 newtons. The block has a static coefficient of friction of 0.20 and a kinetic coefficient of friction of 0.15. What is the force of friction on the box? Well, the first step with any of these problems is to draw our free body diagram. So I'll draw the box as a point for this example, and here we have the weight of the box, which is mass times gravity, the normal force, our pushing force, and the force of friction, which acts opposite motion. So I'm assuming that I'm pushing it in the positive x direction. Now we know for a fact that this box is not moving up or down out of the plane of the table. It has to be moving along the plane of the table. And so if we write the sum of the forces in the y direction, this is Newton's second law, is equal to mass times acceleration. We know that the acceleration in the y direction is going to be 0. And the forces we have acting in the y direction are the normal force minus mass times gravity. And so here we know the normal force is equal to mass times gravity. That's going to be a useful equation later on. So the next thing students usually do is they say, well, they say the force of friction, the static force of friction, is less than or equal to mu sub s times n, and they plug in our normal force, so they say this is going to be less than or equal to mu sub s times mg. This is plugging in normal force. And so then we could plug in our numbers, and we get the force of friction, the static force of friction, is less than or equal to 98.1 newtons. And a lot of students will stop there, but what's really important here is that the force of friction is less than 98 newtons. This tells us the maximum force that we could apply to this box before it starts sliding. So here we say that our force is 50 newtons, and so if we look at the sum of the forces in the x direction is equal to mass times acceleration in the x direction, we have 50 newtons minus the force of friction, and we're charged with finding what the force of friction is. Well, we know that because our applied force, 50 newtons, is less than 98.1 newtons, that the box is not moving, so acceleration is 0. And so our force of friction is just equal to 50 newtons.